A herd of antelope feeds peacefully on a meadow. Suddenly, a lion shows up, and the herd flees. But how do they manage to do so collectively? In a study using microrobots that act like a group of animals, the researchers demonstrate a swarm of animals, taken as a whole, completes an optimum flight response, even if individual animals do not notice the threat or they react the wrong way. The study was published on 7 March 2022 in the New Journal of Physics, NJP. For their experiments, the researchers used a system of microrobots, which are comprised of glass balls that are programmable, active, and spread out finely within a certain area. When the beads are lit using a focused laser beam, one side of them warms up and causes them to move, like animals. We are able to target each individual bead and adjust its movement to fit that of its neighbors, explains Chen, who is completing his doctorate in Bechinger's research team and who was mainly responsible for completing the experiments. The robots in our swarm are programmed to avoid collisions. They also received the information that they were to orient their motion based on the location of the approximate middle of the group. With the help of these rules, the robots organized themselves into a swirl, and Bechinger adds, the microrobotic swarm reproduces the movements of real animal swarms surprisingly well. The flight behavior of microrobots: as soon as a predator appears, the microrobots change their movements. Beck. However, the change in direction is only minimal and does not cause each member of the swarm to move directly away from the predator at any given time. It is striking, however, that the group as a whole moves in a straight line away from the predator. This feat, in which individuals move in a way that is not ideal for each one of them, but where the group as a whole behaves optimally, is based on a collective decision-making process or swarm intelligence, where information is constantly being exchanged between different members of a group. Beck. This shows that missing or incomplete information from individual members of a group can be compensated by other members. The physicists think this could possibly be one of the reasons why animals organize themselves in herds, even though herds are significantly easier for predators to spot than. At the moment, different scenarios are being discussed in which multiple autonomous robots complete a useful task together and in which disruptions to communication between the robots would automatically cause problems. With the knowledge gained from this study, a robotic swarm could work well even if, for example, the sensors in individual robots were to fail. He is also a professor in the Department of Physics. Chun-Jen Chen is completing his doctorate in the colloidal systems research team led by Bechinger. Project funding. Center for the Advanced Study of Collective Behavior, Chun-Jen Chen, Clemens, Bechinger. Collective response of microrobotic swarms to external threats. New Journal of Physics, 2022. 24. 3.0330001, doi, 10. 1088-1367-2630, AC 5374 University of Konstanz. How Animal Swarms Respond to Threats. Science Daily. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.